Today we are going to learn about mastering dictionary comprehensions in Python. You will discover how to create and optimize dictionary comprehensions efficiently, enabling you to write cleaner and faster code. Welcome to our tutorial on mastering dictionary comprehensions in Python. In this video, we will delve into the concept of dictionary comprehensions, a powerful feature that allows you to create dictionaries in a more concise and readable manner. Unlike traditional methods of constructing dictionaries, dictionary comprehensions enable you to write code that is not only more efficient but also easier to understand. Over the next 15 minutes, we'll explore the syntax and structure of dictionary comprehensions, compare them with list comprehensions, and discuss their real-world applications. By the end of this video, you'll be equipped with the skills to implement and leverage dictionary comprehensions for cleaner and faster code. To begin with, let's explore the basic syntax and structure of dictionary comprehensions. In Python, a dictionary comprehension follows a specific format that is similar to list comprehensions. It consists of an expression followed by a for loop enclosed within curly braces. The expression specifies the key value pair that will populate the dictionary, and the for loop iterates over the sequence from which these pairs are derived. Here's a simple example. Suppose you want to create a dictionary where the keys are integers from 1 to 5, and the values are their squares. Using dictionary comprehension, you can achieve this with the following code: x2 for x in range 1, 6. This line creates a dictionary with keys ranging from 1 to 5 and their respective squares as values. The concise nature of dictionary comprehensions makes them an attractive option for efficiently generating dictionaries in Python. The ability to embed logic directly into the comprehension further enhances its utility, allowing you to perform operations and transformations within the loop.
Dictionary comprehensions share a strong resemblance to list comprehensions, both in syntax and functionality. Both allow for the concise generation of data structures, but there are key differences to consider when choosing between them. While list comprehensions generate lists, dictionary comprehensions are specifically designed to create dictionaries. The syntax of a list comprehension is expression for item in iterable, whereas a dictionary comprehension follows the format key_expression, value_expression for item in iterable. The primary distinction is the inclusion of a key_expression, which defines the keys in the resulting dictionary. Both comprehensions offer efficiency and readability, but the decision to use one over the other depends on the desired outcome. For instance, if you need to map keys to values, a dictionary comprehension is the appropriate choice. In contrast, list comprehensions are suitable for creating simple lists. Consider a scenario where you want to create a mapping of strings to their lengths. A dictionary comprehension can succinctly achieve this. Len word for word in, apple, banana, cherry. In contrast, a list comprehension would only yield a list of lengths without the association with the original strings.
Dictionary comprehensions shine in various use cases where transforming or filtering data is necessary. They provide a powerful tool for constructing dictionaries from existing data structures or generating new dictionaries based on specific logic. One common use case is transforming a list into a dictionary. For example, if you have a list of tuples representing key value pairs, a dictionary comprehension can easily convert it into a dictionary. Key value for key value in list _of_tuples. Filtering data is another area where dictionary comprehensions excel. By incorporating conditional statements within the comprehension, you can selectively include key value pairs based on specific criteria. For instance, if you have a dictionary of student scores, you can filter out students who scored below a threshold, student, score for student, score in scores. Items if score greater than equals 70. Furthermore, dictionary comprehensions allow for the incorporation of complex logic and expressions, enabling you to perform operations or transformations on the fly. This capability is particularly useful in scenarios where you need to generate dictionaries dynamically based on changing data.
While dictionary comprehensions are a powerful tool, there are common pitfalls to be aware of. Understanding these potential challenges can help you avoid errors and write more robust code. Firstly, it's important to understand the scope of variables within comprehensions. Variables defined within a comprehension are local to the comprehension and do not affect the outer scope. This means that any variable name used within the comprehension should be unique to avoid conflicts. Another pitfall is the risk of overwriting keys. Since dictionary keys must be unique, if a comprehension generates duplicate keys, the last occurrence will overwrite the previous ones. It's crucial to ensure that the key expressions yield unique values to avoid data loss. Handling mutable data types within comprehensions requires caution. If the value expression generates mutable objects, modifying them outside the comprehension can lead to unexpected behavior. To mitigate this, consider using immutable data types, such as tuples, or creating copies of mutable objects. Additionally, while dictionary comprehensions enhance readability, overly complex comprehensions can become difficult to understand. It's important to strike a balance between conciseness and clarity. If a comprehension becomes too intricate, consider breaking it down into multiple lines or using traditional loops for better readability. Lastly, debugging errors in comprehensions can be challenging due to their compact nature. To troubleshoot issues, consider breaking down the comprehension into its components and testing each part individually.
Dictionary comprehensions offer significant performance benefits, making them a preferred choice for constructing dictionaries efficiently. One of the primary advantages is their ability to generate dictionaries in a single line of code, reducing the need for multiple iterations and temporary variables. This efficiency translates into reduced memory usage, as dictionary comprehensions eliminate the overhead of creating and managing intermediate data structures. Additionally, the compact nature of comprehensions often results in faster execution times compared to traditional methods. However, it's important to recognize the limitations of dictionary comprehensions. While they excel in scenarios where concise dictionary construction is needed, they may not be suitable for more complex logic or operations. In cases where the logic becomes intricate or involves multiple conditions, traditional loops or functions may be more appropriate for clarity and maintainability. Moreover, dictionary comprehensions are not always the most performant option for large datasets. The overhead of creating a comprehension can outweigh its benefits when dealing with extremely large or complex data. In such scenarios, alternative approaches, such as using generator expressions or external libraries, may provide better performance. In summary, dictionary comprehensions offer significant performance benefits in terms of efficiency and readability, but their limitations should be considered when dealing with complex or large-scale data.
Dictionary comprehensions support advanced techniques that allow for more complex operations and logic. By incorporating conditions and functions, you can extend the capabilities of comprehensions to handle a variety of scenarios. Conditional logic can be integrated into a comprehension using if-else statements. This allows you to dynamically adjust the values or even exclude certain key value pairs based on specific conditions. For example, you can create a dictionary that categorizes numbers as even or odd, x, even if x%2 equals 0 else odd for x in range 1. 11. Functions can also be used within comprehensions to encapsulate logic or transformations. By defining a function and calling it within the comprehension, you can perform complex operations while maintaining readability. This approach is particularly useful when the logic needs to be reused or is too intricate to include directly in the comprehension. Additionally, nested comprehensions allow for the construction of dictionaries from multidimensional data. While nested comprehensions can be powerful, they should be used judiciously to avoid compromising readability. If the logic becomes too complex, consider breaking it down into multiple comprehensions or using traditional loops. Error handling within comprehensions can be achieved by incorporating try-except blocks. This enables you to gracefully handle exceptions that may arise during the execution of the comprehension, ensuring that errors do not disrupt the flow of your program.
Dictionary comprehensions find widespread use in real-world applications, offering an efficient way to handle data manipulation and transformation tasks. Their versatility makes them valuable in various domains, from data processing to web development. In data processing, dictionary comprehensions can be used to clean and transform datasets. For instance, you can create a dictionary that maps column names to their respective data types from a dataset's metadata, simplifying the task of data validation and analysis. Web development often involves handling requests and responses in JSON format. Dictionary comprehensions can streamline the process of parsing and reconstructing JSON data, making it easier to extract relevant information and generate responses. Additionally, dictionary comprehensions are useful when integrating with APIs. They can be employed to construct query parameters or headers dynamically based on user input or application logic, enhancing the flexibility and adaptability of your code. By utilizing dictionary comprehensions, you can enhance the readability and maintainability of your code. The concise nature of comprehensions allows you to express complex logic in a single line, reducing the likelihood of errors and making your codebase easier to understand and modify. As we conclude our exploration of mastering dictionary comprehensions in Python, let's recap the key benefits and concepts covered in this video. Dictionary comprehensions provide a concise and efficient way to construct dictionaries, enhancing the readability and maintainability of your code. We've discussed their basic syntax, compared them with list comprehensions, and explored various use cases and advanced techniques. To fully leverage the power of dictionary comprehensions, practice is essential. Experiment with different scenarios, incorporate conditions and functions, and explore real-world applications to deepen your understanding. Efficient coding is a valuable skill, and mastering dictionary comprehensions is a step towards writing cleaner and faster code. With the knowledge gained from this video, you're well equipped to implement dictionary comprehensions in your projects. For further learning, consider exploring additional Python features and libraries that complement dictionary comprehensions. Continuous learning and practice will enable you to become a more proficient and effective Python developer.